Hello and welcome everyone. So I'll be explaining the recent educational Codeforces Run 108 Div 2 problem C. Pretty tricky implementational problem. I did this using two-pointer approach and two-pointer approach. So let's demonstrate this statement first. Basically, you're going to be given a bunch of students' IDs according to their university ID and their like programming skills. Okay. Now the question is that you have to create some number of teams. Okay, the number of members in each team. Now you have to create the teams, but the members of each team can be up to k. Can be k. Okay, any number k. Later they define that k, find out the result for all the k from 1 till n, which we're going to deal with later. But for now, let's assume that number is k. So you're going to be building a team of k integers, and this team of k integers will each and every team will consist of a part of their own university. So there will be university's ID up to n. Okay, a student will consist some of the universities, or does belong some of the university IDs. So we're gonna have to note that too. Now each university will send their k strongest students in the first team. So the way it works is, let's say some university has p number of, or some number of students, and now Polycarp wants some integer k member of the team. So the university will the university will distribute their team members, such as the first k member, or with the highest amount of programming skills, are gonna form one team, and they're gonna go similarly going the second highest programming skills belonging to k of the other students, they will also goes, and so on and so forth. I hope you get that the next k strongest students in the second team also goes like this. But if there any situation occurs where your university don't have the k number of students left, then you cannot put those students into a team or form a team, because they won't consist of k members. So on that case, you need to be considered that the team cannot be formed on that case if the students are less than k. So we should also deal with for each and every universities independently. Okay, so each and every universities will form their own teams with their own students, according to and maintaining this constraint, which is the member needs to be equal to k. So that's it. Now you have to finally find out the strength of the region, the total skill of all the members, all the present teams. So finally the answer would be something like, for any k, just find out all the university's students programming skills sum. That will give us the strength of the region for each choice of k from one, for each choice of k. Now k can be up to 1 to n. That's the tricky part. So if k is not a single value, it can be from 1 to n. So you have to find the result for all possible k, which will be up to from 1 till n. Okay, so that's where the optimization comes, and you need two-pointer approach to do that. Now let's jump into the first example here, which I've denoted here, and I'm going to explain it how actually the answer is forming, and how we actually manipulated and formed and optimized the solution here. So as you can see, of course you want the strength of the region, and basically they have already told us how you're going to be forming, how each and every university is going to be forming their team, of course according to, based on the programming skill of the students. That's what we need. Also we need to care about how many universities are there. Also, one thing to notice too is that universities is going to form teams independently according to their own students' programming skills. Okay, they're not going to be dependent on it. Now that's why we need to form the groups of university students. Let's say I have 4 students consisting of university number 1, and then 3 students here consist of university number 2. So we're gonna be sorting this array for sure. How I did was that I took a structure. Inside that structure I took 2 values. One is a student's ID, university ID, and also his programming skills. Now the way we're gonna be sorting this whole structure type vector is first sort them based on their university, such that they form a group, or the universities form a group like that, like same university students come consecutively connected to each other, and if the universities are same, then sort them like descending order or descending fashion according to their programming skills. That's exactly how I did that. So if I could sort these two types of values, first I did was I took that inside my structure, and then I did sort it, which I've told you how I sort it, and after that, after sorting, it gives us this result, which is absolutely yes, because I've sorted first according to the university ID. If the university ID is the same, then just sort them according to the descending order or descending fashion according to the programming skills, like that. 6 5 5 3 is these are the programming skills of university number 1, consisting of 4 students, and also according to university number 2, there are 3 students. We have distributed them based on their programming skills in a descending order fashion. Now after that, what I did was I used a prefix. I tried to find a prefix array, and inside that prefix array, what it actually defines is, this is actually a new type of innovative prefix array, much like the previous cumulative sum, but just a simple manipulation here, which is, as I've told you, that the universities is going to form teams independently. That's why we need to form our prefix array also independently. What I mean by is, now look, for each and every students, or for each and every universities, I'm going to form their own prefix arrays and then add them into my bigger prefix array, just like that. How did I what did I mean by that? Now if you look at it, I've sorted, right? So if I sorted that, now this group belongs to the university number 1. Now their programming skills, I'm gonna simply do the prefix up till this value, where university number 1's students count ends, and that's what the prefix is offering. I hope you understand well cumulative sum. Using simply cumulative sum, I am just calculating the prefix for each and every group. Okay, now when the index or the pointer comes to a point where it is referring to another university student, at that moment I'm going to stop the regular prefix sum and I'm going to start a new prefix sum. Okay, so that new prefix sum is going to be based on that's first value is going to be based on its own programming skills, and then after that, for each and every students, I'm just calculating the prefix sums. Now why this prefix sum is going to help us? this prefix sum, I hope I made you understand why this prefix sum is acting independently according to the universities, because I'm counting the results according to the universities. Okay, each and every university's prefix sum is going to be their own. That's why when new universities student comes, just dealing and creating or initializing a new value, not depending on the previous value. I hope you get that. Now the question comes, why prefix sum? Why is it is needed? Now to explain that, if I jump down here, they have explained that for the first problem, for the first example, if k is equal to 1, not k equal to 1, let's take for k equal to 2. Now just imagine, now look, if I imagine this example for k equal to 2, what do I actually need to care about? Now if you could see that k equal to 2, right? So if k equals to 2, then the university 1 is going to form a team like consisting of a member where one's skills are 6 and 5, and then he has another opportunity to do that, 5 and 3, right? Similarly, for the university 2, he cannot form more than one team, because if after forming one team, he only one number of students left, which is obviously less than k, so it's gonna have to be greater than or equal to k in order to do that. Okay, so that's how it's actually working. But it doesn't matter how you're forming that. At the end of the day, you are adding all of these things. That's what matters. Okay, I hope you get that. At the end of the day, you're gonna be just adding all those things and just outputting here. Now the question is, how do I know that, or how do I find out that efficiently? For each and every group, I also know that my k won't be a single value. It's gonna be from 1 till n. So I had to also take care about that. So now the next step is that I've created an array. Inside that array, which is the result array, inside that array, it's gonna assign the value for each and every k. So that value will be up to n. So that result array will consist of n members, because we know that k will be up from 1 till n, and inside each and every indexes of that result array, I have denoted that I will assign what will be the answer for if k is 1, or what will be the answer if k is 2, up to n. Okay, I hope you get that. So that's just for the resultant purpose, final result printing purpose. Now the question is, how do I know that for k equal to 1, I'm going to go up to that, for k equal to 2, I'm going to go up to that, or what? So the way it works is we're going to be using two-pointer. How we're going to be using two-pointer? Now remember, what we did was previously we sorted the array, right? So if I sorted the array, I'm going to take on each and every group. Okay, I'm going to take on each and every group, and for each and every group, I'm going to find out that group's member. How many members does that group consist? Okay, now for each and every member, let me explain you here. I hope you'll understand more. Okay, so basically what we're doing is we're going to be finding out the member, how many members does each group have, and for each and every member, just we'll be as we're doing two-pointer. Okay, so the complexity would be up to big of 2 times n, and for each and every group, what I will do is I will turn a loop which is gonna only go for I or k equal to 1 till k equal to length. Now I don't have to go to further of my length of my group, because I know that I will never form a group like that more than my length of my group. Okay, so for each and every group's member, we will deal with, yes, this is our temporary k highest, and we're gonna go from 1 till that length. And what we're gonna be doing is we'll be figuring out how many of these teams that we can make if my ith value is 1, or ith value is 2, or ith value is 3, up to the length of the group itself. Okay, so that's exactly what we're going to be doing for each and every university groups. Now let's deal with the first group. Now we know if I want to form, let's say this is a group consisting of 4 members. Now if I want to form a member of only one student, form a team of only one student or one member, I know that there are 4 possibilities here. Okay, which is basically, if you divide that by which is basically, I'm actually finding out that if I just subtract the mod value of from the group length, subtracting by the group length mod the value that you're working, the k value that you're working with. How is this going to help us? Absolutely, it's just basic basic arithmetic. If you could figure out that, okay, the mod value is this, then we know that before that mod value, I know that I can form something, which is the dividing value itself. That's it. Now for the member 2, I know that I can, okay, member 2, then I can form up to 2 students. Up to 2 students I can form, two teams I can form, sorry. And for if a team member consists of 3 teams, let's say a team member consists of 3 teams, then out of the 4, a team member consists of 3 students, then out of the 4 member teams, I can only form 1 team, which will consist of 3, because after that what I will only left is only 1 student, which is definitely less than k. Now how I am actually figuring this out, that I will only form 1 team, or how many values that I'm gonna have to work with. So basically the problem boils down to each and every group you will figure out, for each and every k, for each and every group you will figure out, for each and every k, what are the values that I'm actually adding. That's it. Now, how you're going to be figuring out? Just subtract the mod value with that k, and that mod values, if you could just analyze, you will understand that what I'm trying to say. Now you're going to be just doing that for each and every group, and then finally, while you do so, you will just add those values inside your result array that I just talked about. Now for more clarifications, let's take you to the code part. You will understand much better inside the coding section. Now look, we're taking n, and then this is the result array that we talked about. This is just basically structure inside each and every value is going to be inside my structure. That's where the structure is building, and this is the Boolean function, which is the bool comparator operator, doing the sorting that we just did and talked about, how we're going to be dealing with everything here. And after that, this is the prefix, so-called prefix, but it is independent of the groups of the students that we talked about, right? That's where the exception happens on from a normal prefix array perspective. Like here, I'm gonna be dealing with, yeah, if it's not, if the, like, this line is actually referring to, if there happens to be something like this situation, then I know that from this I'm gonna have to start a new prefix. Okay, that's exactly what I did here, and that prefix is definitely based on the programming skills. And after that, here comes the fun part. This here inside this loop, and this previous and post, these two lines are definitely and just referring to the group's first member and last member, because if I could somehow find out the indexes of the first member and the last member of each and every university groups, then I know the length of the group, and that's all I care about, because my k will be up to this length. I won't have to go till n, because I know if k is greater than my length, I will not form something like that. So up to length n, k going up to length would be the efficient approach rather than going for that. So yeah, that's what we are looking for. Now j will be up to from 1 till the length that we talked about for each and every group. Now this move value is actually equal to length minus length mod of j. Now why I'm telling that, length mod of j is the axis part, what that we're gonna erase from our length, because I know that length up to len minus len mod j. Again, I'm telling you, len mod j is actually referring to the chunk that we're gonna be deleting that. Okay, that's basic arithmetic. I hope you get that. Now this part is finally referring that the values that we're gonna be dealing with for each and every k from 1 up to length, or if I take k as some value, how many values are there which is gonna form the team. Okay, how many values are there gonna be which is gonna form the team, starting from that. Okay, now yes, I have got that too. Now what I need, this result of j is referring this j, just imagine this j as my k as some value. I know that I'm gonna have to take care of k from 1 till something, so just adding those values in a specific k that we wanna finally output. And what actually is I'm adding the prefix of previous plus the move that I made minus 1. Why is that? Why it's actually referring that? Now first of all, you might have a thought that why is this only adding this prefix? Generally what we do in prefix sum or cumulative sum to find out some range, what we do prefix of r minus prefix of l minus 1. But why in this case we're doing something like that? It's because our prefix is independent. I've told you this prefix is a bit different than the usual one that we use. So I hope you get that. So that's why, as this prefix sum is independent for each and every group, I'm always starting from my starting position of each group. Now this prev value is actually inserting this prev value is actually inserting each and every university group's first index. So if I could somehow find out that, just imagine that we have got bunch of ones and we want to find out the first 3 values, and I have only this index. So what are the indexes that I'm actually worrying about, or I'm gonna be thinking about, is this 2, because I have to find these 3 values. Now if you could see that it's obviously the first 3 minus 1, that's where the minus 1 comes. Now how am I doing that? Now if I could refer the index as 1, 2 and 3, I know that I have to find out 1 plus 2 plus 3. how am I gonna do that? 1 plus, now my move function for this particular subarray, the move function is gonna give 3. Okay, so 1 plus 3 minus 1, what does it give? 3. So I'm only worrying about the prefix value up to 3, this index. Why is this index? This index is actually referring to the group itself, the group's value itself up to that index. I hope you get that. Pretty tricky implementation here, but I hope you managed to understand that. And that's it then. That was the main tricky part here. And why is this actually not big of n square? Because we are only considering that small subarray part once, not n times. That's why this loop, even though you might see that this loop is inside this for loop, but it's actually not going more than big of twice n. Okay, not big of n square. Okay, not going more than big of twice n, because it's a 2-pointer approach like that. Now okay, so yeah, and also this portion here, the last part, this is actually referring that, okay, let me explain you this too. This is actually referring that, okay, you have dealt with this group, but how are you actually managing to find out each and every group? To by seeing this this colliding section, but for the last group you won't find any colliding section, so you would always have to work for that out of your loop. That's why it's actually managing for the last group. After that, just printing those answers, each and every result or each and every k, just managing to answer that. That's all. That's basically it. So I hope I made you understand that. And until next time, goodbye.